Welcome to Indicating and Recording Systems for the Airbus A320. We're going to look at the displays that are in the cockpit by just looking at the information that is on these on the displays and also the computers that are involved. So let's look at kind of the breakdown for this particular instruction. Number one, we're going to have an overview. Number two, we're going to have computers, talk about computers and interfaces. Number three, control panels. Number four, displays. Number five, warnings and failures. And lastly, number six, the crash recording system. All right, let's start with number one, the overview. The displays are obviously very critical as the pilots are relying on what they see on those displays in order to create the right inputs for the desired output. And so maintenance on these is very important, obviously. Your displays are going to be, there's 6 display units. They are all fully interchangeable. And you have captain's side. I'm going to break it up into captain's side and first officer side. Captain's side has the PFD, which stands for Primary Flight Display, as well as the navigation display. Okay, that is abbreviated ND. The first officer side has the same displays I just mentioned, but in mirror image to the captain. So if you were in the captain's seat, the primary flight display will be the far left display, while on the first officer side it's the far right. In the center of those two pairs is the ECAM for your electronic centralized aircraft monitoring displays, and you have 2 displays there. One's the upper and the other's the lower. That is abbreviated ECAM. So ECAM is the abbreviation for the electronic centralized aircraft monitoring system. Okay, so upper ECAM and lower ECAM. Now, how does the information get there? Okay, that information is being delivered to those graphic generators that are part of the displays by the DMCs. DMCs are the computers that are feeding signals to those graphic generators so that obviously the pilots can see what's on there. Okay, so DMC stands for data management computers. There are 3 of them. So far we have 6 displays and 3 DMCs. Your DMCs are designated or labeled as DMC1, DMC2, and DMC3. Now, I mentioned there's captain's side and first officer side. The data management computer 1, the DMC1, is responsible for sending signals to the captain's side's displays, while the DMC2 is responsible for sending signals to the flight officer's displays. And by the way, it's a two-way street, so even though we have the majority of signals, digital signals, that are going to those graphic generators, we also have feedback signals coming from those displays back to the data management computers. Okay, that's just enabling, making sure things are displaying properly. Now, there is the DMC3. That particular data management computer is a backup. So that's just giving you an idea with if you have a failure of 1 or 2 of the data management computers, for running pilot and first officer's displays, the DMC is the backup for that. So it will take over whichever one fails. You also have, of course, control panels. You're going to have your control panel for your flight instrument system, as well as your fault or warning systems. So your flight instrument system is actually, your flight instrument system control panel is located on the glare shield. Okay, and then you have your ECAM control panel, which is in the center pedestal. And then warnings, you do have a central warning system. That warning system has your flight warning system. Those are your flight warning computers that are there. And then you also have your system data acquisition concentrators. Those are all part of the warning system. And there's 2 of those. Okay, those are acquiring most of the signals. Okay. You also, we're going to get more into the computers as we continue on, but just kind of giving you an overview of that. The other thing too, there's some preventative systems on board. There's a thing called AIDS, and I like to spell things out, or say the actual words, because there are so many acronyms in any industry. But this AIDS actually stands for Aircraft Integrated. You have integrated data. So with this, you have it's monitoring, and basically what it's doing is enabling or giving information that will help with preventing, basically preventing failures, because it's giving that information ahead of time. Then maintenance can actually say, oh, okay, here's a problem here. It wasn't critical, but it was brought to the attention of maintenance, and it can be addressed then. So you have that particular preventative system. Okay, that's called AIDS. It's not something that most people probably are familiar with, but it's just a data system integrated as we continue to have more electronics, okay, and on aircraft, which is your avionics. Then they're going to be implementing or installing more preventative types of systems, and AIDS is one of them. And just to note, not every aircraft may have that, but if it does, you'll know it's there for basically lowering the number of maintenance that has to be done, because it's, again, monitoring a lot. Okay, also one of the things that AIDS does, it's used for tasks like the hard landing detection, so detecting hard landing and monitoring. Okay, so this kind of give you an idea with the computers. I mentioned data management computers. You have flight warning computers when we talk about fault isolation, that whole central warning system. And then also some of the interfaces we'll get into a little bit more, but the electronic clock, or electrical clock, it may not seem like a big deal. I think, well, what's the big deal about having a clock? But this has to do with how it's timing or recording faults. So it's actually a pretty important component with the whole thing. All right, so that kind of gives you an idea that some of the things that we have on the displays, I'll just get into it in the next sessions, but just an overview that gives you an idea with the electronic instrument system, which is the displays with the computers and interfaces. Okay. Now, when we're looking at the electronic flight instrument system, because I mentioned, remember I said on the glare shield that you have your control panel for the flight instrument. The displays that you have with the electronic flight instrument system, I mentioned about captain's side, first officer side, and each of those sides has a primary flight display as well as a navigation display. Those two displays are part of that flight instrument system. And then your ECAM, has to do with warning messages. So it's going to have your upper ECAM is going to be predominantly your engine warning displays, and then your bottom part, that lower ECAM is going to show either your system pages, or I'll explain what all the system pages are, but you'll have system pages or your static, or it might get a synopsis of something. So there's some synoptic pages, which just means it's giving a summary of some information. All right. Okay, that gives you an idea on just an overview of of the indicating and some of the recording that goes on that would show up on these displays. As far as what these displays are. Now let's go ahead and move on to number 2 with the computers. For one, where are they located? Okay, well, I know we have an avionics compartment on the aircraft, but where specifically are they? They are in the main electronics compartment on the right-hand side. Okay, right-hand side of the aircraft in the forward bay. That's probably a test question. Okay, main electronics compartment on the right side of the aircraft in the forward bay. Okay, with computers. Okay, let's go ahead and get into some of these. Your computers, you're going to have your data management, remember I mentioned the data management computers. Data management computers are going to be split up as far as their job in sending signals. Remember I mentioned how DMC-1 is responsible for sending signals to the captain's side. Okay, that means his primary flight display as well as his navigation display, and also the upper ECAM. So that's an added little thing. DMC-1 also sends signals to the ECAM upper ECAM. And then your DMC-2 is sending signals to the flight officer's side as well as the lower ECAM. And then I mentioned about the DMC-3, of course that's your backup. Now, the nice thing about if there's a failure of display on any of them, these DMCs are designed or have a switching relay. So you may hear the term switching a lot because, you know, it's important that, you know, you have a switching of information from where it should be displaying to some other display that actually is working and functioning. Okay, the idea is obviously to get the data there so that the pilots can see, you know, the reality of what's going on, status, etc., or any faults, you know, whatever warnings are going on. Which, by the way, there are some oral warnings with the displays. You have on the panels, you've got the oral warnings and chimes, master CAUT, okay, your CAUT, as well as your master warning. Okay, on switching. Okay, what happens if you have, let's say a pilot has, you know, he has his two displays in front of him, whether it's the captain or first officer, right? And one of the displays should be displaying, you know, at all. It should be showing something, but it's not. It's dead. Then that DMC, okay, that's in charge, it's gonna, you know, through the output switching relay, it's gonna be able to still show, okay, it's gonna be able to still show the information on the other. There's a selector switch if there's a failure. Okay, so let's just say that one of those doesn't work, and in particular if you have a DMC that doesn't work, then, you know, it can actually, there's a selector switch. Okay, it's the EIS DMC that can be, you know, turned on so that the DMC-3 can take over DMC-1. Okay, if it doesn't work. There's also a selector switch or push button switch for switching the screens. So primary flight display can be, that information for primary flight can actually be seen on the nav display. So it can cross change those images if it wants to, but that switch enables it to transfer those two. Okay, and you also have a way to do that with your ECAM displays as well. There's an ECAM ND transfer button, and that does the same thing, from moving from upper to lower. Okay, so let's just say that you have a failure of the system. By the way, your lower ECAM is your system or status page. We're going to go into the system pages in a bit, but the upper is for engine warning messages, and then your lower ECAM is for your system pages that can be shown, like, you know, for hydraulics and just different things we're going to go over, or status. And usually your status page is what's happening. You know, maybe it was a failure, things got kind of recovered, and then it's letting the pilot know, you know, what the current status is. But let's just say that you have a failure of the lower ECAM, that's your system or status. Then you're going to have an engine warning image remain. That's going to stay intact on the upper ECAM, but it's also a single display configuration. So with that, you can have a replacement of that, you know, engine warning image, and can be replaced by any other page. So whatever needs to be shown that was going to be showing on the lower ECAM, but lower ECAM failed, I'm talking about the lower ECAM display, then it could actually temporarily show up on the upper side, the upper part of it. And there's a selector switch, like I mentioned earlier. It's the ECAM ND XFR selector switch, and the pilot can call on that, okay, for ND on an ECAM image, for example. That's why it's ND transfer, because you can show nav information on an ECAM display. So that's a lot about the switching. Just know that it's possible to do that, because we want to make sure all of that information is available to be seen. All right, let's go through a few test questions. These are, I'm going to mention them from time to time as we go along through the material, so it's fresh in your mind. Question number 1, what two subsystems make up the electronic instrument system? Okay, is it A, electronic centralized aircraft monitoring system, that's your ECAM by the way, and electronic flight instrument system? Or is it B, your full authority digital engine control, which is FADEC, and your navigation system? Okay, the answer is number 1, or it's A. Okay, the first answer I just said. All right, question number 2, how many displays are there in the cockpit? Okay, as we're talking about indicating and recording, is it answer A, 5, or is it answer B, 6? Okay, the answer is 6. Remember, there's 2 displays on each side, 2 for first officer, 2 for captain, and then we have an upper and lower display for the ECAM. Number 3, what drives the operation of the displays for primary flight and navigation? Okay, your PFD and your ND is what I'm talking about. Okay, is it going to be A, your flight warning computers, or B, the data management computers? Okay, that's going to be your data management computers. All right, number 4, what drives the operation of the displays for engine warnings and system status? Okay, driving that, is it going to be flight warning computers or data management computers? That's going to be your flight warning computers. Okay, warning, right? Has to do with engine warnings, flight warning computer. Number 5, of all the computers involved with the electronic instrument system, which one acquires most of the signals? Is it system data acquisition concentrators or your flight warning computers? That's going to be number 1, right? System data acquisition concentrators. All right, let's look at one more question. Where are the computers located? Is it A, in the main electronics compartment on the left-hand side of the aircraft, forward of the cargo bay, or is it B, the main electronic compartment on the right-hand side of the aircraft, forward of the cargo bay? All right, that answer is B. Remember I said it was the right-hand side. All right, let's go ahead and go back to on our computers. I mentioned the data management computers. We also have flight warning computers, and the flight warning computers obviously have to do with the central warning system, and that is interfacing with the ECAMs, the ECAM displays, right? Because we're talking about warning messages that are going to show up on the upper ECAM. So that's what you have with the flight warning computers, that they're generating those warning messages. And also, along with warning messages, for example, typed up on the actual display, you're also going to have the pilot and first officer is going to have the auditory warning. So they'll have these, and visual things. So there'll be a master caution or master warning caution come on. There's also oral, which is, it's going to be a chime that comes on. Okay. You have red warnings and also your amber warnings. Your amber warnings are coming from the system data acquisition concentrators. Inputs that are going into the flight warning computers obviously are going to be generating those warnings. Okay, so just to keep in mind with when we talk about computers, you have flight warning computers. And also just so you know, since we're talking about primary flight display information, then we're going to be talking about interfaces, or you're going to be aware that there are interfaces with other computers on board. For example, you have your flight management and guidance computers, and those kind of come into play, here and there. So It's interconnected with things that make sense. Okay. All right, so that kind of covers your computers. And then we just want to make sure we cover some test questions as we go along here. Let's go ahead and cover some. Number 7, what is the function of the data management computers? Is it A, processes the data from the inputs and then sends those signals for graphic instruction to the displays? Or is it B, processes data from inputs and then sends the signals for management of the SDACs? Okay, SDACs is your system data acquisition concentrators. Okay, the answer is A. Number 8, what is the function of the flight warning computers? Is it A, creates the warning messages that are displayed, or creates the status messages and provides a preventative method for safe flight? Okay, that's going to be A. Number 9, which displays are driven by the DMC-1? Is it captain's displays or the first officer's displays? Okay, that's going to be captain's displays. Number 10, if DMC-1 fails, which DMC takes over the functions of DMC-1? Is it DMC-2 or DMC-3? That's going to be DMC-3. DMC-3 is your spare, it's your backup. Number 11, if the pilot wants to switch the screens he has in front of him, namely, obviously we're talking about the PFD and the ND, right? Primary flight display and your navigation display. Which push button switch would he use? Is it A, the EIS DMC, or the PFD/ND XFR push button switch? You're right, it's B. Number 12, if the pilot wants to put some ECAM image on his nav, okay, on the ND display, ND, he's not able to do so. Is that true or false? That's false. Remember I said he can. There's a push button that has ECAM/ND XFR on it. He would use that push button switch. All right, number 13, one of the interfaces is the flight augmentation computer as it relates to the centralized fault display interface unit, or central warning system, okay, because that CFDIU falls under that. Remember I mentioned the flight augmentation computer. So the answer is true. That is a true statement. All right. Let's look now at number 3 as far as our information, our subtopic, and that's looking at the ECAM. So let's get into detail on what's on the control panel, what all is ECAM about, etc. And let's look at what we have here. With the ECAM, remember it stands for Electronic Centralized Aircraft Monitoring System, or Monitor System. You might see it different ways, really doesn't matter. What makes up this monitoring system? Okay, remember I said you have upper and a lower part. You also have the flight warning computers, or the ones driving. In other words, they're sending those signals to the graphic generators that are part of those ECAM displays. You have an upper lower, I mentioned that. You also have 2 concentrators. Those are your SDACs. That's your system data acquisition concentrators. That's where it's getting most of those signals and then actually sending those out to the warning computers. You also have master warning, and also 2 and 2 master warning lights and your 2 master caution lights, or caution lights. You also have loudspeakers. There's 2 cockpit audio loudspeakers, and then of course you have the DMCs that are just part of your flight instrument system. But in particular, when we talk about ECAM, we're talking about engine information, engine warning information. Now, the bottom third, and I'm talking about that you have an upper display, right? The upper part and the lower part. Well, just within the upper, let's just deal only with the upper display. With that area, you have the top part of that display is going to show your fuel quantity, your flaps, slats, position indications, anything engine related, your engine indications. And the bottom part, which is just a smaller part at the bottom of that upper display, is going to have memos. Okay, and it also has some warning and caution messages. They'll give the title of it. We'll go into the classes of failures when we get to that topic. And then now we're talking about the lower one. So let's move on to the lower display. Here it's going to give a diagram, basically a summary diagram that's corresponding to the phase of flight that's going on at that time. So you have that information. Also information or explanation of some downgrading that might be, some capability there with downgrading. You have indications of the aircraft status that would be shown after a failure, was detected. You also have some other information like your speed, altitude. There's some emergency postponal procedures and other information that might show up on that lower display. So think of the lower display is going to be your status after a failure, and then also just it's going to be system pages, which we'll get into. Also, another thing, since I'm remembering this, there's permanent data that will also be there. Now, an example of permanent data will be, for example, gross weight, your total air temperature, things like that, the time. So just kind of giving you an idea on some of the parameters that are considered permanent data. Now, what kind of push buttons do you expect to see? And you can see on your handout, I didn't put all of them, but just some examples. Your keyboard for the control panel is split up into two parts. You have your system keys and your warning keys. Your system keys obviously have to do with your systems on the aircraft, right? So we're talking about hydraulics, your electrical system, your air conditioning, your flight control system, your APU, pressurization, air bleed, air engine bleed, your fuel, things like that. And then, of course, when we're talking about warning, you're talking about an emergency. So you have your EMER cants, so EMER space CANC, your 2 config, your status, you have status, and then you have your RCL for recall. Your clear, you have your clear button. Those are warning keys. And those are your 2 categories, is your system keys and your warning keys. Now, there are some keys that are directly connected or directly wired to the connector. Those are not going to be your system keys. Those will be things like your clear, your CLR key, and your STS for status, and your emergency cancel. That's EMERCANC. And they have an ALL key, an ALL key. Okay, those keys are directly wired to the connector. Okay, so that gives you an idea of what is on, displaying as far as the keyboard, the control panel. All right. Okay, so that's for the ECAM, and then let's go ahead and see what kind of test questions that you might see, because I don't want to forget that. Question number 14 on your handout: which computers are part of the electronic centralized aircraft monitoring system? Is it A, flight augmentation computers, or B, flight warning computers? It's going to be your flight warning computers. Number 15, the upper ECAM displays engine-related warning messages. Is that true or false? That's true. Okay, so let's go ahead and go back and get some more information on what you have with the ECAM. Remember I mentioned that the lower ECAM displays system pages and also it gives status, but let's look at the system, because there's, I mentioned, the hydraulics and all that. There are 11 system pages. You also have a cruise page besides the status page. I mentioned the status page, but there's also a cruise. But there's 11 system pages. Okay, what are they? Okay, you have your engine secondary parameters. Okay, your engine secondary parameters, we have, it was mentioned also in the power plant topics, all the subtopics. There's mention about the parameters, because there's primary and secondary. Anyway, bottom line is it's going to show system pages for the engine secondary parameters. So we have engine as a word. for one of those pages, and then your air bleed, which is the word bleed. You also have your hydraulic power, which is abbreviated HYD, so you'll see that. And then cabin pressurization is designated with the phrase PRESS. You also have fuel, so that's FUEL. And then you have flight controls, which is indicated by the phrase F/CTL. You also, your doors and oxygen are put together, so you have a display that shows door/OXY. You also have air conditioning, which is by COND as an indication, and your APU, and also your landing gear, wheels, and brakes. That together is indicated by the word WHEEL, wheel. Okay, and then you also have, I mentioned electrical power supply is going to be ELEC. So you have those. Those are your 11 pages that you, or different pages that you have, with at least 11. Then you have a cruise page that's going to show up when, obviously, when the flight phase is cruise, right? As far as the different phases of flight, one of them is cruise. So when that happens, the cruise word will show up and be displayed on the ECAM. All right, now your status, that's on system. Your status page, what's that showing? Remember I said that status is like, okay, what's your status now? What's the current status? Well, it's going to give status, which is very important, after a failure, because it wants to see, was it corrected, and pilot needs to know, is everything good now? But that's, or if there's not, basically it's giving the information on that display. So you'll have a status page that's going to give the summary of, what happened after a failure. There's a particular key, it is STS for status, by the way, that is a key on the control panel. Okay, so that exists there. And remember, it will give the type of failure, or the type of class, failure class, because there's different ones. And that'll be displayed on this page. Okay. All right, let's make sure we don't forget some other questions. Okay. Question for you. This is, if you're following along in your handout, this is question number 16. How many system pages can the lower ECAM display? Okay, is it 11 or 15? Okay, the answer is 11. Okay, and number 17, when does the status page display? Is it A, after the pilot pushes the PFD, ND, XFR push button switch, or B, when a failure occurs? Okay, it's B. Okay, when a failure occurs, or after that. Number 18, into which two parts is the ECAM control panel divided? What two parts? Is it A, system and warning, or is it status and normal? Okay, the answer is A. It's system. Remember I said there's system keys and then there's warning keys. Obviously those are the two parts, by name. Okay, number 19, which of the two keys is directly wired to the connector? Here are your two choices. Okay, choice A, is it the emergence key, or is it B, the COND, COND for air conditioning? Which one is directly wired to the connector? Because of importance, right, for right away information. Okay, it's going to be the first one, your EMER space CANC. Okay. All right, so that gives you an idea with what kinds of keys you have on the control panel for the ECAM, as well as displays, what kind of information is displayed on the upper and the lower ECAMs. Okay, now let's go ahead and move along to the actual displays. That would be the primary flight display, your navigation display, and your ECAM displays. I know I mentioned some there, but let's just kind of go a little into talking about navigation. Some of the displays, things that you're going to see on the navigation display is going to be your ROSE ILS mode. This has to do with localizer and glide slope deviation indications. So you have that. Also, you have ROSE VOR. Okay, if you took the navigation class already online, then you'll understand some of these words. But anyway, that's there. And then you also have your ROSE nav. You also have an ARC. Your ARC mode is showing map information. And then you also have a plan mode, which is going to display the static map. But that map is with respect to true north and centered on a point that the pilot decides, what that is. Okay, so that's your navigation display modes that you'll find there. And then as far as your primary flight display, information obviously having to do with the aircraft's position and speed and how high it is, etc., and where it's heading. So for example, on the primary flight display, you're going to have information about speed as well as your vertical speed, your altitude. You also have heading information, tracking information, trajectory deviation information that's going for during your ILS approach, I should say, for pilot, or your ART-NAV approach, and then also your guidance. Okay, that's from flight director. Bars, symbols are going to be on there for the guidance information. Okay, and just kind of a side note, if for some, just so you know, the heading and the altitude windows there for those are actually a grade background. Okay, so you have a grade background is showing when there's speed, heading, and altitude information. When there's a fault in the ventilation blower or the extract, it's that background is going to kind of fade out. So that's just a fact, just so you don't think maybe there's something wrong. Vertical speed, by the way, just so you know, there's a green pointer and also a value number is what I mean for vertical speed. Okay, we'll get to, hopefully you get to see some pictures so you understand, or just get a visual on it a little bit. Okay, so those are just some of the things you'll find on the primary flight display, and information on the navigation display. And then I mentioned about the ECAM. I already mentioned you're going to have engine information, like for example fuel quantity as well, things like that. All right, so I think it's time for some questions again. Okay, let's kind of go over some questions real quick. On the displays, what can you find on the ND, your navigation display presentation on display? Okay, it's going to be your flight mode enunciator or ARC mode. Okay, that's going to be B, your ARC mode. Number 21, I'm on number 21 on your handout. Which display shows the heading or the track information? Okay, tracking information. Is that going to be your ND or PFD? Okay, it's going to be your PFD. Number 22, ENG, comma BLEED for bleed, right? Comma PRESS for pressurization are displays that you will see on which display? Is it on the ECAM or on the ND? Okay, that's going to be on your ECAM, right? ECAM will show the engine information. Okay, number 23, where is the permanent data displayed on the ECAM? Is it A, large area at the top of the display on the system display, or is it on this in a small area at the bottom of the display on the system display? Okay, it's actually at the bottom. The answer is B. Number 24, what's an example of permanent data? Is it empty weight or gross weight? Okay, empty weight's pointless, right? When the aircraft already has passengers, pilot, and cargo, and all kinds of stuff. Okay, we're talking about gross weight. So that's the answer. Okay, now let's go ahead and move to our next topic, our next information piece. We just covered displays. Now we're going to talk about warnings and failures. We're also going to mention the bite and some classes of failures so that you understand it if you don't already have some familiarity with the classes of failures. So let's go ahead and get into the central warning system and specifically what I'm talking about. And then we have different equipment related to this. Okay, so let's look at with the central what we have on central warning systems. We have to have a fault display, right? Display of faults to begin with. So we have an interface unit. Okay, that is your CFDIU. That is your centralized fault display unit. And that's receiving fault messages from various aircraft systems, right? Remember all the systems I mentioned that were on, system pages. It could be your hydraulics, your cabin pressurization, right? You have a pneumatic system with all of that, your electrical, okay, your engines, all that. So that centralized is central for a reason. So that's what I call centralized, because it's gathering all the faults that could, whatever's coming through. It's, as far as detection of faults are going to be going to this interface unit, and it's going to take that information and store it, because it's going to regurgitate that. It's going to portray that on reports that you'll be able to extract from the system, to see what's going on and when it happened and all that. Your display interface unit has 2 channels. It also has modes. The 2 channels are going to be your normal and your standby. And then as far as different modes that you have, the modes are going to be menu and normal. With the normal mode, that's always going to be active unless the plane's on the ground. And when plane's on the ground, then you have a menu mode that's selected. You also have your bite, which is a central part of aircraft. Okay, your built-in test equipment, that's what it stands for, which is going to be memorizing all those failures, etc., for all the systems. Okay, your ECAM is monitoring all the aircraft systems and delivering that information to the fault display. A fault display system. Remember, your MICDUs also is where you see a lot of information. So your multi-purpose control and display units are also there, part of that, and is being used by the CFDS to show those failures or whatever, and also do an interrogation using the bite tests, etc. Okay, all right. So you have that centralized display interface unit. Now let's go a little into some understanding of the classes of faults, because you can have a fault, okay, great, something's wrong, but well, how bad is it? Do we need to land the plane right now? Do we need, what do we need to do? So how bad is it? And we have 3 different classes of failures. Your class 1, class 2, and class 3. Your class 3 is your least severe. So your class 3 is kind of like I'm not saying you people have been in any trouble at all, but in some industries, like for example with the law enforcement, which anyway, I'm familiar, that's kind of my familiarity is with just being an instructor on another end, how they classify crimes, right? Like if something's petty, it's going to be a class 3. If it gets a little worse, maybe it was up to more than shoplifting, so maybe they robbed a bank, whatever. It goes into class 2 and then class 1, so it gets more severe the lower the number. Well, it's the same thing here. You have class 1, 2, 3, but if you want to look at it as class 3, 2, 1, it kind of makes sense, because what's not really that critical is a class 3. That means you can be left, without being corrected right away, and can kind of just wait till the next maintenance check. Your class 2, all right, it's getting a little up there. We need, it's detecting those class 2s. It doesn't affect the safety of the aircraft, but it's something that needs to be dealt with when the plane comes to ground, maintenance needs to go and investigate it and find out what's going on. On a class 1, those are your most serious. Class 1s, think about class 1, priority number 1, emergency, because now it's jeopardizing the safety of the aircraft, and there needs to be immediate rectification of whatever is going on. Whatever's wrong needs to be addressed by maintenance right away. Okay, so we're down to the nitty-gritty of just bringing it up to a minimum equipment list, with making sure all of those all the equipment on the MEL is functioning the way it should. So that's what we have with class 1, class 2, class 3. Just to note, on the class 1, remember I said that's the heaviest. That's the one that requires immediate maintenance. Class 1 has 3 different levels. Level 3, it might be confusing, I'm going back and forth as far as severity, but within class 1 failure, you have 3 levels. Level 3 corresponds to a very emergency. Okay, that means something has to immediately happen without delay as far as rectifying that situation. Your class 1 level 2 means that it's not a normal configuration, but it's not a crisis emergency. So it's an in-betweener. They need to, crew needs to be aware that they need to be addressed, but it doesn't have to be addressed extremely right away, but it definitely needs to be corrected. And of course, class 1, level 1, it's a configuration that needs to be monitored, and it can cause a loss of integrity of the system. Again, it's a lower, less severe. So I hope that did not confuse you, because those arrows went in 2 different directions within one class. And then as I was describing the umbrella or the helicopter's view of classes of failures, I said class 3, 2, 1, class 3 not being so bad, and then we escalate to get a little more serious. That's class 2, or class 2. And then as we get to like, oh my gosh, this is really bad, this is an emergency, then a severe thing, basically jeopardizing the safety of the aircraft. Now we're talking about class 1. So just we can look at that again, but I hope that gave you some knowledge of the severity or the importance of the classes of failures and how it isolates, because it's determining the system itself. The computers are determining, based on a logic, and all these and the variables and parameters as to whether or not it's classified as a class 2 or a class 3 or a class 1. You know what I'm saying? So that's interesting. Like how does it seems like it's subjective, but we know that there's requirements in place for equipment to be functioning so that the plane be considered or deemed as safe to fly and land. That's the bottom line. Be able to have the plane flying safely and landing safely, and equipment that's intact will ensure both those conditions. You have system byte, of course, the reports that come out. Your reports, you have, by the way, there's different types of systems. You got type 1, type 2. Now I'm talking about another type 1, 2, 3, etc. But, here we're talking about type 1 systems. These are your systems that can record failures across the last 64 flight legs. Okay, I'm probably jumping ahead a little bit, but it came to mind now, so I thought I'd just mention it to you. Back to byte, okay, your built-in test equipment and the reporting that goes on. There's a constant monitoring that goes on with the operations of the systems on the aircraft. And it's going to be storing and, sending out signals to the right computers and interfaces, etc., so that we're back to the cockpit again, to make sure that the pilots who are flying the plane are aware of those failures, right? And what to do, or something was corrected. So detecting those failures, that's what byte is there. The computers obviously have a byte circuit to do that, in order, have that to detect those failures. And of course, it's storing all this information. Okay, it's making sure that all that information can be in a report that can actually be printed out. And by the way, I don't have to go into detail about the printer because it's not the most exciting piece of information about it, but there is a printer, okay, that actually has paper, and you can print out. There can be a printout of these reports. Okay, you also have remember I said the centralized fault display system that's centralizing all the information regarding the failures on the aircraft, and that can be either read or in print because there's a printer, and that's going to be all accessed through the MCDUs. All right, of course, then you have your current leg report. You also have your last leg report that's available. And the way that I mentioned I know I briefly mentioned about the electrical clock earlier when I was talking about I was in the overview section. Electrical clock is important because it's noting when something happened. It's important to note time. It's just when you think about, if you worked on, obviously you have worked in aircraft, but I was thinking specifically of oil leaks, because oil leaks are timed. And it's important to time it so that you know, okay, well, how fast is that? You know, what's the rate of leakage? Because if it's going at a certain rate that's slow, you know, again, it's just timing it, then it's not so bad. It needs to be looked at some point, but it's not critical. But if it's leaking, you know, at a faster rate, then it needs to be dealt with immediately. So it's important that the electrical clock is working properly in order to record those times of those failures and all that data. Okay, so you have, again, current status, and kind of the way it shows, it'll show the time in, it'll show the time there, it's the mean time, so it'll show it in that. It's called the Universal Coordinated Time, by the way. So you'll have that as part of the information. You also have a system report /test. That's your system report test function. That one is only available on the ground, so that cannot be accessed or done in flight. That is something that's on ground only. And what it's doing is it's being able to have the information from the fault display system communicate with a system computer. Okay, but remember, this is done on ground. And then you have, of course, all the different systems, the reports on the different systems. That's why you have a system report test, because it's going to hit every single one. Remember I said there's 11 listed, and it's just going one by one. So it's going to be that centralized fault display interface unit is going to be communicating with the computers for each of those systems. Okay, your hide system, your electrical, pressurization, engine, obviously, things like that. Okay. All right, I don't want to forget some test questions for you so you can be up to speed here. All right, let's look at, get out your handout again. Let's go back to your handout. I'm on question number 25. Okay, let's look at that. There are two channels to the centralized fault display interface unit. What are they? Is it A, normal and standby, or is it B, normal and alternate? Okay, you're right. It's the first one, right? Normal and standby mode. Standby channel, excuse me. Number 26. Of the two modes of the centralized fault display system, which one is active except when the plane is on the ground? Is it A, menu, or B, normal? Okay, it's B. Okay, active mode is normal. Unless the plane's on the ground, it's going to be in a menu mode. All right, number 27. What does BITE stand for? I know that I threw in a freebie there for you. Okay, what does BITE stand for? A, built-in test equipment, or B, backup integrated test evaluator. Sounded good, didn't it? Okay, the answer is A. It's built-in test equipment. Number 28. Which class of failures is the most serious one? Is it A, class 2, or is it B, class 1? It's class 1. All right, number 29. Failures can be uncorrected until the next scheduled maintenance check. Which class of failure does that describe? Is it A, Class 2, or B, Class 3? Okay, that's Class 3. Remember I said 3 is not so bad. Okay, number 30. Which type of system can memorize failures that occurred in the last 64 flight legs? Is it type A or type 3? The answer is type 1. Okay. Number 31. The electrical clock is one of the interfaces with the centralized fault display interface unit. Is that true or false? Okay, you're right, it's true. We are on to now our last topic. This here is crash recording. I call it crash recording. They're not calling it crash recording, but that's what it is. It's crash recording. I'll give you its official name. Official name is digital flight data recording. But the purpose of this is to record the flight parameters to fulfill requirements of a crash recording. So that's what it's there. And then you have interfaces. You got your flight data interface unit, your management unit, okay, that are part of the recording system for flight, for what happens when the aircraft's in the air. So it's going to take all that information and store it. Okay, you have a push button, what's called event. So EVENT is a push button that exists, and that is installed to record an event mark on the tape. Okay, event push button is located on the cockpit center pedestal. You also have an underwater locator beacon, because what happens, what if the aircraft, sunk right into the sea, So now it's underwater. This beacon, obviously a beacon is so that you can locate something. So you have that existing with this whole system. And then linear accelerometer, that's going to be located close to the aircraft center of gravity. Accelerometers measure the acceleration, obviously, of the aircraft. But when we talk about linear accelerometer, we're talking about it gathering the data of acceleration in all three axes, right? Okay, that's what it's doing. And then, of course, you have a control panel as part of this. Part of your control panel is a push button that is indicated by GND space CTL, that is for ground control, that allows the recording to be powered up when the aircraft's on the ground. Okay, and that's actually before the engine starts. Okay, now all these interfaces, like I just mentioned, the management unit and all that, those are connected to the system computers in order to collect those parameters. Okay, so all that. Your flight warning computers, your DMCs, remember your data management computers, although all those are connected to your management units. And that's all so that it can do the testing and gather any data regarding failures. Okay, where is this located? Where's the crash recording equipment located system? This unit, it's actually located in the unpressurized area of the rear fuselage. Okay, so just remember that. You'll see that as a question. Okay, so, and remember two push buttons again, just review. Okay, EVENT for event, and also your GND space CTL for your ground control. Remember, that's only on the ground. And just note that you have that locator beacon, and that's on the front face of the actual digital recording equipment. In case the plane goes underwater, there's a way to locate it. All right, so let me go ahead and go over some questions, and we'll be almost done here because I mentioned about AIDS. Okay, I'm talking about aircraft integrated data system, but let's go ahead and go to just a few questions. Number 32 on your handout. Which recording system is used to record crashes? Is it A, the centralized crash recorder, or is it the digital flight data recording? The answer is B. Number 33, where is the DFDR, okay, digital flight data recording, located? Is it A, the unpressurized area of the rear fuselage, or B, the pressurized area of the forward fuselage? The answer is A. I just mentioned that. All right, just one piece of information. I know I mentioned earlier, I just want you to get it in your head because it's not something that you find on every single aircraft, is your aircraft integrated data system. And this here exists when you have a lot of electronics on board, being able to basically monitor so much, because it's able to, because it's electronic, it has that ability to do that. I'm talking about from other systems being electronic. Is that now it can gather and monitor information like crazy. It's like, okay, now we have the ability to do this. And if there's something that maybe doesn't seem quite right, it's just kind of almost like a backup monitoring system that basically saves a lot of time, because it's able to get information almost ahead of something that might be a problem later, and that can be just addressed a lot sooner and avoid extra maintenance hours on something that took maybe 2 hours now, or would take less hours than if they hadn't caught it earlier. So it's monitoring trending that's going on with certain systems, for example the engines or the APU. And again, the whole idea here is to cut costs and time and all that good stuff. So okay, so I just wanted to leave you with that. If you have any questions at all that came to mind while you were listening to this whole instruction, please send us an email. Let us know your thoughts and maybe your experience as well, because that's valuable. If you have any questions at all, please email us, and we'll be happy to answer those for you.